Okay, are we live? I think so we are. I think yes. Okay. Should I play some music? Um, so that we can feel little better, right? So mhm. So let's say some work music, something nice. Hmm. Okay. Uh, this is not what we are doing. Trying with reversing and splitting collections. Okay. I think uh, I need some rushed code logo, right? Okay, the thumbnail can be illegal or something. How about this one? Uh, it looks nice for a logo. Let me save in a screenshot or something. Yeah, maybe. Who cares? Okay, right. Let me change the logo also. Change images.jpg something. Right. And now we are good. Okay. So should I start? Hmm. So what is my plan for today? I think I have a good plan. I want to split the collection. I want to reverse the collection, and yeah, that is the plan. So I have reverse algorithm already, but what I want is a split algorithm and reverse algorithm, but the other way around, right? So let's see how can I do these things. Screen key, let me turn on the screen key so that we can be a little more visible of what I am typing. Okay, so collection extension, right. So here is uh, some plans. Hmm, uh, anyway, to do.md, I don't know, and to do.md. Okay, so oh, what is that? I think it's very some important things. I have not removed that. Today. Okay, so I need to have error dot reversed. Error dot reversed dot reversed is ARR, right? So that is the thing. And error dot split by, right? And mod e uh, predicate of e. So these are the things I want to do today, kind of. And I think split by mute is a thing, and uh, split, there is also split, and there is also split mute. I think there is also uh, hmm, there is also max number of splits or something. I do not know. There is also max number of splits. So, but for the time being, I would try to implement this one. I guess there is. Okay, so what is the order? Right, this is the order, and split by. Okay, and split by split. What should be the algorithm name? So I need some good algorithm name. Yeah, let's read that. So I need a good algorithm name for RSSTL that produces split iterator for collections. Now I have split by and split algorithm, but there also exists an algorithm that takes max split count and returns at max count plus 1 splits. What is that algorithm? Yeah, so split n, split, yeah, split n and split at most, yeah, split at most is the thing. So split at most by, right, at most by mute, and similarly uh, what should be the thing? This by is not needed, split at most mute. So these are the algorithms I need to implement. Like there are literally so many of them, right? But I think this is these are the two, those are most common ones, and then the other twos I can implement like simply based on that, just calling the function on that. So yeah, let's try that out. Okay. Yeah, guys, we're doing that. Okay, so collection, I guess I would have a reversed collection, and the last time it did not work because I did have wrong iterator design. Iterator was coupled with my collections, but I think I have to get rid of iterators because yeah, iterators are not my concern, right? Uh, at any time I can produce some iterators using split, so why should I worry about iterators at all? And then iterators can handle themselves, so that was not my concern at all. Anyways, so yeah, let me take the copyright notice, paste it here, right? And uh, pub mod reversed, right? And let's make doc inline pub use reversed collection, right? I think that would be there. I think there are more, but we'll see. Okay, so pub struct reversed collection, right, of C, and uh, where C is a collection, and let me include collection, and base is C, right? And how we will create reverse collection? It will be simple. I guess um, IMPL C a reversed collection of C, where C is a collection, right? And I need a new method that just returns self, and this new method takes C, that means base, and yeah, what it does is returns reversed collection of base. So this should be the one for reversed collection, right? And what's the problem? um, I think it's saying field in this struct is right, is not being used, so that's fine. uh, IMPL collection for and we do have one more method, and that is reversed, and it would give me C, right? And it would consume itself and return self dot base. So that is another thing, right? And I also want self dot base, because you might want to get the base, and yeah, that's fine, right? Now IMPLC collection for reversed collection of C, right? So now let's start implementing the collection things, right? And I think the problem here is it should be bi-directional collection, right? So that should have been the case, but yeah, let's see. And C, the whole of C is a bi-directional collection, where okay, code trait bi-directional collection is not satisfied. So yeah, wow. Type position is nothing but C position, element is nothing but C element, right? Element ref is nothing but C element ref of A, right? Whole is nothing but the whole thing of oh, whole is this thing? I do not think so. The whole thing is self, right? The whole is not internal one, so it should be self, right? So start, I guess start should be self dot end, and end, okay, self dot base dot end, right? And end should be self dot base dot start, right? Yeah, C core bidirectional collection is not implemented for C. The whole, okay, it should be bi-directional collection. And now things are looking fine from the point of view of LSP. So for next, so for getting to the next element, you basically next position, you basically go to the previous position here. So self dot base dot uh, prior basically. Okay, form prior, right? And you pass position. hmm And for accessing the current element, what you do is you have the element. You are like, okay, self dot base dot uh, uh, prior, right, of I dot clone, and you take the reference of the whole thing and you do self dot okay, not whole, where was that, base, and you return this thing, right, and dot at, so you return the position. So let's say if I'm at end, I'd go just before that, and yeah, I'd return that thing, right? And then there comes slice, and for slicing, uh, what is slice? So I think, right, uh, slices should be like uh, okay, I would like to have slice like that, right? And I do not know if I want to have like a reversed position or something, but yeah, slice new from and 2 is good enough basically, right? So yeah, and self slice new from 2 is good enough. So I want a slice from here to here, I just get that, right? It's not a big deal. Hmm. Now we are quite okay with getting reversed collection as a collection done. Uh, what I should do is I should try to implement a bidirectional collection for the same, right? Because it's a bidirectional collection too. So implement C and uh, bidirectional collection for reversed collection of C, where C is bidirectional collection and C whole is bidirectional collection. And yeah, I need to have self dot uh, base dot form prior, form next, and next for position, right? And that should be the case. Um, I have some problems with this thing. So one thing is, do we need comparable positions or something? So, right, for random access collection, so I should think about that one. I think it's the comparable position thing is very important, and I just did it wrong. So what I should do is I should have something called reverse position. right? So that should be pub struct reversed position, right? And hmm, and reverse position of p, okay, and base position is basically p, right? So that is the thing. I think yeah, that should be the case, right? So reverse collection, uh, and we have base position, that is p. This seems nice. Now the position should be comparable. Okay, IMPL order for p, and I think derive partial equal and clone are simple, but the ordering of those position are not as same as the opposite one, right? So implement missing members. Okay, and so what we do is where p is order, right? So how do we do that? Oh wait, cannot compare because partial order is not implemented. So I need to implement partial order, right? How to implement partial ordering? Implement partial order for reverse collection. Implement missing members. Okay, nice. So we have this partial comparison thing, and hmm. So what I can do is I can do some sort of matching here, pattern matching here. So I do a match, right? And here what I have to do, where p is partial ordered, right? So I do match, and yeah, a missing arm. I think it should fill missing arm. So none is basically none, so that's not a problem. Sum of e is there can be sum of multiple things, right? What is that? D is this. Yeah, there can be sum of multiple things. So what e is? E is basically ordering. So let me go to ordering. Okay, how can I do that? How can I go to ordering? Okay, there is less, equal, and greater. So sum of less, right? So it should be instead comp ordering greater equal. It should be equal, and greater. It should be less, right? What happened? And it should be sum of it. right? So yeah, that's it. Like this is the partial comparison, and now when I do this copying thing and paste it here, I need to implement ordering and order DAF, and I'm like, okay, give me missing members, right? And how do I compare now? And yeah, the comparison is simply, I think, match self dot base position dot compare with other dot base position dot compare other dot base position, right? And I do match it, and this time I'd copy this one, okay, paste it here, and here is the thing, right? Df this, this, and okay, other dot base position, and this is the reversed position, right? So now we have reversed position. I guess it should be called reversed collection position, not reversed position. But yeah, let me change that. GRN collection position. Okay, nice. Now we have reversed collection position and reversed collection. I think what I can do is the position is basically reversed collection position of C position, right? And yeah, uh, what it does is at any point it would have uh, reversed collection position base. Oh, reversed collection position. What's the base position? It's base position only. Base position and self dot base dot end, right? Similarly, here it should be start, right? And yeah, this one is a little tough, right? Let me take this thing this way, base position, and so it's next, right? Self dot for prior, self dot uh, base dot for prior, and the prior should be of position dot base position, right? Hmm. I guess this is something we what was that? Position dot so self dot position is reverse collection position, so it should be base position, right? Or no? What's the problem? I think it's fine. I would not care much. Um, Now let p is basically self dot base dot prior of uh, I dot base position, right, dot clone, and what you do is you return self dot base dot at this whole thing, right? And this completes the reversed collection thing, collection implementation. So let me try this out. Cargo test. Let's see how it performs. uh, yeah, it compiles. So that was not a problem. That means all of this thing were actually good. Screen key activating, right? Now yeah, now let's try to implement bidirectional collection for the same, right? There are other things I need to take care of, but for the time being, uh, I would first implement this thing. So for me, it's simply for next, right? So that, yeah, that just works. Hmm. So bidirectional collection is implemented, but now there are things I need to see. So I have to implement unwrap type to type argument. See what is that? No. Implement default members is something I want to see. There are uh, other things I have to implement. So for example, these are the default members that were implemented badly. So I would implement that, right? Uh, so how to implement that? I think implementing them is just calling form prior n, right? And call n, something like that. And yeah, it should be again form prior n limited by and n and limit, right? Mismatched. Okay, form prior n. Wow, I think bidirectional collection is wrong or what? Form prior n limited by, that is correct, right? Found struct expected type this position. Okay, position dot base position and limit. uh, okay, that is self position, but this, it should not be self position. Should be limit dot base position, right? And that should work. Hmm. Wow. This is a hard one. So now next, I guess next and next and all of this, how it should be. So should it be like self dot next and position dot base position? right? Hmm. Something like that. Self dot base dot next. So yeah, that can be one way to implement it. I don't know. I'm not sure basically how effective is that conversion. So I am relying on that. This one is more effective. So let's go on. Uh, Next n, and you pass n here, right? And you get the same thing, right? And limited by position dot base position, and limit is limit dot base position. Wow. And wow. Next and limited by mm, okay, how it should be. I don't know. Self dot base dot next. And limited by this thing dot map E is basically reverse collection position base position of E, right? And that should be the thing, right? uh, Distance, I think so. Distance is nothing but self dot base dot distance from to from. So just the two dot base position to from dot base position, right? And that should give me distance. So self dot base dot count is good enough, and self dot base dot under estimated count is again good enough. Whoa, watch it. It's a lot. It's a lot. You have to do a lot to make these things working, right? Uh, yeah. What to say? Okay, nice. Let's go more. Should I implement default members for the same? So again, from prior and all these things. Oh, this is just a lot, man. This is just a lot. One thing I would love to do, but before that, let me do form. Yeah, I just copy paste many things, so it should be just form next 10, right? And similarly, this thing should be form next n, right? And for this you return. Oh, did I mess up here little. Yeah, it should be prior. It should be prior n. It should be prior n, right? Where is next, 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 right? So yeah, that's fine. Now prior n, and it should be next n. Right. Let me go to okay, nice. So we implemented bidirectional collection for the same. Now it's time to implement random access collection uh, for the same, right? So I would implement random access collection. Let me import that, and now the thing is uh, everything should be random access, and that's how you implement random access collection. I think that's all you have in random access collection, right? uh, yeah, that's it. So how do we implement reorderable collection, lazy collection? There's so many of it, right? So let me try doing lazy collection, right? uh, Lazy collection, and yeah, I have to implement, so it should be lazy collection plus bidirectional collection, and similarly lazy collection plus bidirectional collection, right? And I have to implement the missing member, right? So it's nothing but compute add. So I would just go for the add function. I would call the same, and I would just call it with compute add, right? And you're done. That's how you do it. Okay, now we do have lazy collection implemented. I want to implement mutable collection, I guess. Mutable collection is something I like. Reorderable one. Okay, reorderable collection. Let me import it. Reorderable collection. Reorderable collection, but it should be bi-directional also. So yeah, and we implement the missing members, right? So how do we implement the missing members? FC, right? Hmm. So how do we implement the missing members? I guess it's quite easy. For this one, you basically swap at I dot base position, j dot base position, and you take the references of both things, right? So yeah, that is good enough. Now for implementing the mute one, I think I would just go slice, slice, no, 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 okay, so it should be literally slice mute new self from 2, and it should be 2 dot base position to from dot base position, right? Argument to this function are incorrect. Okay, so yeah, it should be simply self from 2, nothing more, and that's it. I don't know, there should be some slice function, right? How is it even possible that slice function is not there? Slice self from 2. That's it. Okay. So now we do have reorderable collection. The last thing that we really need is mutable collection, right? Uh, and it doesn't know what is a mutable collection, so let me tell it what is a mutable collection. Let me implement the missing member, and again, how would I implement the missing member, right? And this how would I do? Oh, not that way, not this way also, this way, but now not compute at mute, at mute. And that's it. This is all we have. Like the reverse collection implemented in RSSTL. Uh, yeah, that's so nice. Okay, yeah, guys. Let's see if I got a little bit of person. No? Okay, fine. Hmm. Uh, Now you should try writing some tests for the same. So I would do that. Mm, tests. So reversed collection dot test dot rs. So let me try doing that. I would get some. Wow. I'd get some tests from this place, right? So let me try doing that. Yeah. Has test fn. Uh, so how to test if it's reversed? I think the basic way to test is cloning and all. So let me do that. Test the quality, right? So the way you do it is uh, the way you do it is what's the way? Let ARR is 1 2 3, right? And the next statement is like, okay, ARR dot reversed, right? um, okay, dot equals 3 to 1 assert. So this is what we do. Let's see. Okay, we do not have reverse method for the collection right now, so let me do that uh, by directional collection extension. And what you do is yeah, fn reversed, right? Returns a collection whose elements in reverse collection, right? uh, Post condition, I guess no allocations are done for, no allocations are done for new collection for forming new collections. What is next? The next is complexity, I guess. Complexity is basically order of one, right? And what you do is you do reversed collection of self. Yeah, import that. What's the problem? Hmm. Hmm. So there's some problem. Uh, I think we need to do reversed dot rs, and here I think if C is not sized, that's fine for us at least, right? So I guess because we are storing the same, C should be sized. Uh, so where self is basically sized, right? Okay, now this is fine. Uh, yeah, these are the things we do not want to deal with in high-low when we are writing the language. Anyways, yeah, this is the reversed collection. Okay, so now I can go for reversed collection test and I can run it. It works. Okay, uh, I might want to try a little more of condition, right? And one more. One, two, it should be 2, 1, right? And it should be 1, and it should be I32 comma 0, right? And this is how it should be, right? Let's see. And all of this is working. So uh that's fine. I think I should check the slicing. Okay, so slicing is something I guess is really important. So fn slicing, right? So let ARR is basically 1 2 3 4 5, right? And what I can do is dot reversed let ARR is basically this thing, right? Wow, that's nice. uh, and error dot prefix, let's say I take 3 elements from starting. Okay, that should be 543 dot equals 543, right? that should be the case. So yeah, that's the case. Now my point is prefix up to, right? And with prefix up to, let's say, uh, okay, let me take suffix. Suffix is more uh, interesting. So it should be 3 to 1. Wait, there is some problem. Okay, let me go for core.rs suffix uh, collection extension, and we have prefix things, right? And let's say if I take the full prefix, let's say like 7, so it should be 54321, and here also it should be 54321, right? Okay. Hmm. Subtract. Okay, now we got into an issue. The suffix 7, suffix from suffix max length. Okay, so if what's that? It's self dot count. Okay, so first let me start with the prefix 3 and suffix 3, and it should be 3 to 1. Uh, okay, subtract with overflow. So suffix is not working at all, right? So let's see. Max length 3. I think self.count itself is not working. That is my assumption. Mm, right. So n is this thing. So we can never get into if max length is greater equal to n, right? So we basically return the full thing. So that should be fine. If max length is greater equal to n, it should be full thing. Otherwise, hmm, reversed collection reverse.rs. Self.base.count, and base.count should be fine. So that should not be a problem. Where is problem coming from? I think that should be the problem. Let me try. Oh, oh, suffix was not the problem. Wait a minute. Suffix is fine. Problem is not with suffix. It's prefix 7. Okay. Let me go and check what is the prefix implementation. For next n limited by. Okay, what's that? Ah, form next n limited by. So form next and limited by is wrong. For sure it's wrong. Form next and limited by. What is this? Increment reachable from position. So let me try if uh, we have the basics right. So we do have the basics right, but this prior thing was not right. Hmm. So should I try to draw this one like with GIMP? I don't know. Is it that hard? Okay. So here is the collection. Okay, and I am here, right? And I need to go n, but limited by this one, and that is n. So this is what we do. um, so how is that wrong? Self-des form. Hmm. I basically do not know. Okay. Hmm. Uh, so we are at the base position and we limit till the base position. It's a problem. So let's say what would happen if it would do prefix call. Let me go like that, right? What would happen if it do prefix call? So it would take self dot start, right? So let me draw that all of it. So self dot start, that is this one, okay? It would call it end, right? And for next n limited by max length, right? So okay, let me draw like this. I have 1 2 3 4, 0 1 2 3 4, right? And this is the fifth position. Take है. E is basically 5 जो कि is there. Now form next unlimited by end, and max length is 7 for us. So okay, form next, and so currently let's take it as okay, multiple of end, right? Max length, that is 7, and this one is basically S. So limited by this thing, right? Now what it does is for the base one, it calls from form prior n limited by. So uh, form prior n limited by, and now the base position is what's the base position? Mm-mm-mm. So is 5, right? Max length is still 7. Max n is still 7, and S is 0. Hmm. So 570, this is what it happens, right? Let me try this one. Let me try this one. So uh, let ARR is 1 2 3 4 5, and ARR dot form prior unlimited by, okay, let mute e is arr dot end e, and what's that? 70, right? Let's try this one. Okay, and it says subtracting. Okay, so the problem is in the array implementation. That is so bad. That is so bad. The array implementation has problem, and we are discovering it at this point of time. Whoa! How will I do this? Uh, wow. This is what I'm doing. Let's go for the standard implementation and fix it. Okay, for prior and limited by. Okay, so if form next and limited by. Okay, so we are at position P and we subtract n, and this can get negative, and that's a problem, right? So what we have to write is if the position is greater than limit plus n, then we do this. That's a bug. That's a subtle bug, right? Let me change it for form prior. For that it will not be there. Range, I think range it might be there. Form prior and limited by. Limit plus n as self position right, form prior and limited by, and dt this paste plus, and yeah, that should be the case. And I think we only have two such one. I will have to say how many times I have done minus, because these minuses are problematic, right? So let's go for slice form prior and limited by dt this plus plus right, and last is vector form prior and limited by. Okay, nice, and now it should work. Yeah, this works. So now I'd go and implement prefix of 7, and it should be 54321, and it is. But we have found a really subtle bug, right? It was a tough one to solve. Let me commit that bug at least, because that bug is a nice one. Reversed collection. Collection, reverse collection test. Bi-directional collection. I guess this is for array. Slice this. Vec. Okay. Implement fix for prior and okay. Yeah, that was a settled one. Anyways, so similarly for suffix 7, it's exactly the same because it is, right? And what's next? With prefixes, we have done that. We have suffixes. We are quite done. Okay. Are there any more tests I should do? So like prefix 0 and suffix 0? What do you think? Something like this? I think that's fine. It should work. Uh, yeah. What's next? Um, we have done the equality. We have done the slicing. Right. Uh, I think it's a quite nice thing, and I can try doing a cargo test. Is there something remaining for I think there is something remaining. So ordering test, right? Fn slice position ordering, right? So arr dot start, let I is this one and j is arr dot end, or what I can do is assert arr dot start is less than arr dot end. Okay, is equal to and this does not work. Wait a minute. Okay, because this is end, it should be start, and this again does not work. Wait a minute. Okay, because this thing, and yes, the positioning should be like this only. So the ordering of the position should be inverted, and that's it. This is something I like. I think I want to go through a PR way so that I can actually check if everything is passing, because I have done a lot of changes, right? I do not know if I have reverse.rs, a collection that presents element in reverse order of base collection. So that is something, the base collection, and uh, positions of reversed collection, uh, ordering of positions should be inverted in reversed collection, right? So that is there, and then we do implement, yeah, runs the returns a new instance of reversed collection created base from given base collection, returns the base collection, right? This over the okay IoT base collection. So we are done with some sort of these things also. One thing I did not verify till now is uh, is uh, mm, one thing I did not verify is swapping, I guess, swapping and element access. So that is something I did not verify till now. So mutation is something I can say I should verify. So YAF this thing paste, add a test marker here, mutation, and verify the mutation. So that is what you do to verify the mutation. ARR dot swap at ARR dot start, ARR dot prior, ARR dot right. And now if I do that, uh, it should be, so if it was 54321, ARR dot equals so it was right 54321. Now it should be 14325, and this does not work again. Shoot, index out of bounds, len is 5 but the index is 5. Do you see what is happening? So this is what happens, like the element access you are doing is the wrong one. Collection reversed RS swap at and what you do is um and I swap before the prior positions, right? What's the problem? Cannot move behind the shared reference. Okay. Mm, what? As does not run copyright. Okay. So make it clone. Who cares? Right? And now it should work, right? So that is something I should call reordering. That is something I did not test. And what did not I test more? I guess element mutation, right? So error dot at mute, error dot star is basically 3, right? And yeah, it has some problems again. um, so how we do it, let I is error dot start and I pass I here, like that, right? And yeah, that's it. And what happens is you return at mute, and it should be 5. Okay, 3 4 3 2 1, right? And I need to assert it. I did not assert it there. Fine, it works, man. That was a big one, right? uh yeah, we are doing a lot. We did a lot. Reverse.rs, I think I did a lot. mm, and not in this one. Get checkout minus b impl reversed collection. Okay. uh feet implemented reversed collection. Let me open a PR for the same, so that I can actually check if my cargo clippy is working well, right? So that should be the case. My cargo clippy should be working well. github.com. Hmm. Right. We need to implement a lot, like a lot, right? Just to get this reversed collection working. And it feels good. It feels good if without iterators I'm doing good, right? Because I was really pissed with the state of iterators and Rust. It doesn't seem like they have been so great. Anyways, how are things? Hmm. Okay, I need some water. We'll take a small break, and then I would see what should I do with this one. So, how much break? Timer, right? Let's add a timer. Okay, I'm back. So we have done a good amount of work. I do not know if there is something I should consider more. But yeah, what's next? I can try implementing split iterator. That is something I think could be nice to have. And then for tomorrow, I can move towards sorting. So that can be a plan. I can play a chess game basically to have some fun, right? A 5 by 5 chess game. Play. So I would not go for rapid because rapid takes a lot of time. And I'm not much interested in playing rapid right now. Okay, position seems quite simple. We are developing. I do not know what uh, is there. I think it's better to get back once, right? So that this knight is unpinned. Now, uh, I think I want to have more center control. So for the same, I would simply exchange the bishops and then I can try some more fun things, right? Hmm. I still have he has the same problem. Like he might want to trade with my bishops, but first of all, I want to trade some of his, and then I will see. So I think opposite color bishops are now there. If it takes now, I have some concern. How should it be? I do not want to double my pawns to be really honest, so I will not. Hmm. But the game now goes for uh, what should be uh, the center control, this, that. Like I'm attacking, he might want to defend, but then I will attack that. Yeah, and I don't know how to feel about this position, right? Uh, the knight is planted in my position, so that is bad. Uh, One thing I can try doing is, but yeah, that would be a disaster, right? If I do that, it simply gets to a fork. So not that. If it takes, I take like that. Hmm.
I have to go like this and this. I don't know how this thing is going. Till then, I can also see if my reversed collection implementation is going fine. Uh, is there something remaining in tests? I don't know. Let's see what he plays.
He gets away with the bishop, with the knight. I do not know if the knight has some other good position. I am not seeing any, right? How he will maneuver. That was the only good outpost it had. This is what seems to me, right? If he comes here, I will take, and I am fine doubling his pawn. So, oh, this one, fuck, what I'm doing? Yeah. Fine. I have to go back and that way, and then my knight would have some problems, like some real one. Oh, he wants to come here, and I do not want that. So maybe this way I can also try opening the position, and but my king is now really unsafe, like really, right? There are more things, I guess. Wow. My knight is useless right now. It's, it's so useless. I do not want to play this move. Otherwise, in the next one, I will need to play this move so that my knight is not trapped somewhere. Right? Let me play this one. Uh, and I am forced to play something like that. Hmm. And the basic attack is on this one, so I will have to defend, right? But now, okay, and now I'm trapped. Now I'm trapped. I'm simply trapped. Oh, wow. This is disastrous. The only thing is if I do this, he takes, and that's bad. If I do this, he takes, and that is also bad. The position is disastrous. The only good thing I'm seeing is this one, but then what about this thing, right? Or not this one, okay. But somehow I feel my knight would be trapped somewhere. I will do that, but that would simply go into okay, yeah, it was bad decision. Uh, wow, that was so bad play. And then this, my knight is still trapped, so I will have to take special care of it. And at some point, he will try to fork me with his knight. Currently, at least, my rook is doing some good thing. Yeah, I don't know. I do not want to.
Where should I go? This way? It's so bad. Like, this way seems so limiting for my pieces, so I did not go that way. Hmm. Are there any audience here? Maybe, maybe not. I don't know. I should focus on my reverse collection thing. But this one is so nice of a work. With the old iterated design, that was bad, but now it looks so good. Okay, yeah. I might want. Oh no. Okay. Uh, I might want to hide somewhere. My only concern is my knight currently is so ill placed. And now he has like wow. Yeah, this is the only way to save knight, right? Because otherwise but this passed pawn is just too much. I cannot handle that passed pawn. uh, yeah, first of all, I think, oh, then my rook can be a problem. Wow. uh how much problems this position has? A lot. So this one or this one? With this square, I am thinking of some escape path or something, but I don't think I should escape forward for the time being. Let's go with this one. And I think that is something incoming, and I don't know what to do. Let me till then let me actually merge this PR. I am not getting any case that actually have the that should be remaining, right? I think I have all test cases. I think I have all. So yeah, let me merge this one. Anyways, oh, we can play on time. uh he is trying so much to. Now I am suspecting this thing, but yeah, all my pieces are just not working well. This check is for getting rid of time pressure. Oh, what happened? He might want to do that, but let me come here then. He wants to exchange, that's for sure now. No, he doesn't want to exchange. Okay, he's just trying to bring some time. Oh, come on. I would be more than happy to draw. Yeah, I know. I do not have option but to exchange. And shoot. Hmm. Can I do this? Then he takes, then this, but he can just move away, right? But that is not. Uh, no way. Yeah, he's killing. I sh wow, that's a reasonable position. That's a reasonable one. Wow, what a bad game from my side. Uh, I'll try one more and then I will try doing the split iterators thing in Rust. Uh, I think now take yeah, and mm, this one and this one. This is what I'm suspecting. And even then I can do a castle, and the next thing should be this. Okay, it is going exactly that way, but I do not want that. Okay, he doesn't want to exchange queens. There is a really nice trick here. If I castle and he takes, then I can just do this one and his bishop is trapped. But that is a hope chess. I just cannot hope that he does that, right? But at least, anyways, I'm going to castle, and he's going to castle same way. Nice. Uh, what should be my plan then? Uh, I think it's a good time to undouble my pawns and remove one defender nearby from his king. Yes. And with some of this play, I might try to do more fun. Hmm. Till then, I should think about the design of my split iterator thing, right? Because split iterator is an interesting one. So if I think about it, not this way, oh what, delete, yeah, okay, he played, it's bad. uh, my rooks are not connected, but I have a good feeling that playing this move kind of is nice because, you know, discovered attack. Previously the bishop was defending. Yeah, you do that, and then you basically trade, and I'm a piece up, and now my whole game is going to be around exchanging the pieces, and that's it. That's my game. Hmm. Okay. I have an attack on this pawn, so we'll see if I can take this pawn, right? And I think it's nice to just, yeah. Now this one with intentions to go on the 7th rank. Oh, and see. This is how you blunder. What I'm doing. I should be coding and I'm okay. What should be my way to answer this thing? Okay, I will have to take. Uh, nice. Mm, fine. Still, I can proceed with my intentions, right? And that would be fine. Now, his rook cannot move, at least. So, this kind of attack would be really nice to have. Doubling on 7th rank is a nice thing. What is the design of split iterators? So basically, I have a collection, right? And I want to split where I want to have a split where algorithm where if the predicate satisfies, I would split. That is my goal right now. Okay. Hmm. The intentions are clear here, at least, right? So, and uh, it would be iterator of slices. So, uh, not the generic one in Rust, but the one I designed for RSSTL. And I think at some point my slices would be generic ones. So there is a need of basically there is a need of changing the standard library a lot. Like when I say a lot, that means a lot. Yeah, I didn't get even a high. And now you know the best part is if I take and he takes, uh, that's a checkmate. uh, First I want to get rid of this thing, then this thing, right? I suspect he tried to come here. Okay, not here. That's nice. Okay, what happens if I try to do a check, right? This is a check. Mm-hmm. And with this check, he cannot take because that's a checkmate, right? Uh, check this thing and then this. And if he takes, I take. But if he comes here, then what? Oh, did I mess up the position? Hmm. So let's say if I take this thing, if I take this thing, okay, no, this take, check, but he decides to come here. I do not have solutions to that thing. I think one more protective move and then I. Okay, now I have some plan, right? This pawn is highly vulnerable, like highly vulnerable, and I will take this pawn. He takes it. He goes this way. If he goes here, that's simply a win. But if not, like wow, I don't think he will go this way. For sure. Mm, I could not get advantage of the position how I wanted it to be. I think that's a bad move because it's simply blunders this pawn, and now I can try like pushing. Okay, what happens if I exchange like this one? This, but then I push, then he should go back, then I push. Okay, takes. Oh, just this going back is good enough, right? Mm, it's not as easy. Uh, so I cannot go with this, but I have set of fast pawns, so Oh, I could trade. Oh man. Yeah, I could trade. Yeah. Okay. What about this one? I go here. Where do you go? He goes here. I go here. I think it's winning, right? I go here. He goes here. I go here. If it takes this one, I take, and that's fine. Push, push, win. That's a push, push, win thing. Push, push, win. Right? Hmm. Yeah, and now he cannot go that away, because if he goes that away, I will take these pawns, and yeah, he resigns. Push, push, win thing, right? Okay, did I do some brilliancy? I don't think so. There was some brilliancy. Uh, it might be possible that I did something, but yeah. Oh, I did. Wow, that's nice. I think so. Where was the brilliant thing? Right. All of this for classic. This. Yeah. Uh, yeah, I'm good here, here. And okay, that was okay. Yeah, I had to do like. And then I decided to win the end game, and there also I was losing, but yeah, it was not that. Oh, he had to come here to stop me, but he decided to go there, and now it's a fully winning position because yeah, that's it. Anyways, I'm done with the streaming. I will try doing another stream maybe after some time, but yeah, I'm done currently. Uh, that's all I had. Split iterators, I think I could not implement. That was a problem. But let's see. Should I try? Should I try? It's a big story for the time being, right? A split iterator, like you go and implement this one. I don't know. I think I'd that would be a good learning session at least for someone who is trying to learn some API design. But I think uh, there are very less people in universe that who knows API design and trying to learn API design. So, anyways, we are done. Uh, I will end the stream. Thank you, Jai Shri Ram.